Hey guys and gals, it's Mr. Veeth. Hey, we are on to, I know it's been a little bit since we've done a video, but we are on to a next topic in multiplication. And this topic um, can be easy to do, but sometimes hard to understand, and even harder because the order technically can matter at times. So you're going to have to really slow yourself down to understand what the problem is saying. And even further, I'm teaching you this now because the next concept we do is going to even matter even more. So what we're going to be doing right now is we're going to be multiplying fractions. And the two ways we're going to multiply fractions today is we're going to take a whole number and times it by a fraction, and then we're going to go opposite, a fraction by a whole number. Now, here's the cool thing when it comes to the outcome, comes to the answer. You should know by now that if you multiply, say, 2 times 3, it's 6. But if we reverse the order, which is called commutative property, you should know that. 3 times 2 is also 6. But depending how it is, 3 times 2 can look different on a picture or hanging curtains or something like that. When it comes to area, it can be different than 2 by 3. So we're going to focus on the order a little bit. But the cool thing is the outcome would stay the same. Okay, but we're going to make sure that we get into the deep understanding of it. So make sure you have your notebook with you. You are just going to be on the next page of notes right after our adding and subtracting fraction notes. Okay, so this is going to be, I'll try not to make it a too long video, but it's actually going to be a 2-part video. So you'll only have to watch half of this tonight and half of it then another day. Multiply fractions and wholes. So that's going to be our title. Multiply fractions and wholes. So we're going to multiply fractions and whole numbers. And the way that we're going to do it is we're going to multiply whole by whole. We're going to multiply, I did that wrong, sorry, fraction by a whole. Okay. Now, there's a couple things that we need to know, that we need to remember. And that's, what does the multiply sign mean? This is going to be huge. In fact, I taught you this earlier this year, and this is the reason why. This unit that we're starting is the absolute reason why I taught you this. Hopefully you remember multiply means the word of. Okay? So if you see the word of, it means times. Okay? So when we're going to think about that as a lot, because that's going to help us deeper our understanding. Another thing that you're going to see it can mean is, if you ever see as much as, that also can mean times. Okay? So if you see these two words in word problems in the correct context, it's very much going to mean multiply. Now, what I just said by what I meant by that is, it doesn't mean every time you see the word of in every word problem here on out for the rest of your life means multiply. That's not how that works. But in the right context, of a lot of times means multiply. Okay? So, and that's how we're going to further our understanding on this when we start doing this. The other thing that we need to know is we still have the what you have and the what you're doing. So we did this with normal multiplication and normal division, and we'll see if you remember it. So this does not go with, like, on a numerator. You know, numerator is what you have. Denominator is what your pieces look like. That's going to be super important today too, because again, all that comes in. That's why this gets not tricky, but all the pieces I've ever taught you start to come into play now. And that's why it was important all year to pay attention and make sure you know what you're doing, because now we're using all the skills and putting them together. So in multiplication, what you have goes second or last. What you're doing or want goes first. So that's huge. And we'll hit on this for a while, but this is a big one. What you have is second. So think about it. If I say I have 3, if I have 1/3 of a pie, I want 3 of them. What does that mean? I want 3 of the 1/3 pies. That's what that means. So it's going to take a little bit for you to grasp, but if you slow down and let your brain open, I promise you it's not as hard as what it could be. Okay? So we're going to do some problems here, and we're going to try our best to make sense of this. Okay? So let's see what I can do here. Let's try a problem, and let's try 3 times, let's go 1/2. Go pretty easy. 3 times 1/2. Now, I don't want you to just see this problem and think 3 times 1/2 and try to solve it. I want you to understand what this problem is saying. Okay? I want this problem to talk to you. And the more you understand what's going on, the more this is going to make sense, the more the easier it's going to be down the road. And when we get to division, the less you're going to get this confused because you're used to slowing yourself down and thinking about it. I promise you now, this is a beep moment. If you just focus on how to do it after I show you how it works, and all you do is focus on the outcome and how to do it, I promise you everything's going to get hard, and you're going to forget, and you're going to get them confused. So stay with me here, okay? So what we want to do is I'm going to write the word of right above here, and I got to come up with some stuff. Okay, we're gonna make a word problem in our heads, okay? And that's what I want you to do. Every time you got a problem, I want you to make a word problem in your head. Doesn't have to be a hard word problem. Doesn't have to be confusing. Just make something up, okay? So remember, what the first number, what you are doing or want is first. So this is what I want. I want 3 of something. Okay? So this is where you get to make something up. I want 3 donuts. I want 3 of them. Okay? So I want 3 of this. So this is what you have. The 1/2 is what you have. I have 1/2 donut. So that's what I'm going to draw. Okay? I have 1/2. Boom. Always draw what you have. So when we're drawing pictures, draw what you have. Okay? Because again, what you have goes second, but it's what you have. That's what you have it, and you're going to want more of it. So we have to, in order to want it, you have to have it. Kind of say that with me in your head or say it with me out loud. In order to want something, you have to have something. Okay? I can't, if I want 3 donuts, or if I want 3 half donuts, I have to have. They have to be there. So here's the 1/2. Okay, so there's 1/2. I just drew it. Now read the problem in your head. I want. So you can even put the words "I want" here. That's how I want you to think about it each time. I want 3 of 1/2 donuts. I want 3 of the 1/2 donuts. So that's what I want you to picture in your head. If you want 3 of them, and that's what we're going to say, 3 of them. 3 of what? 3 of the half donut. Well, I want 3 of them. So I'm going to draw another donut, cut it in half, and I'm going to eat that half too. So there's another half donut, but I said I wanted 3 of them. So I'm going to make another third donut, cut it in half, because again, what does our denominator tell us? Denominator tells us what our pieces look like. So our pieces look like halves. So there's my 3. So now I have 3 1/2 donuts. So now you got to ask yourself, what do I have? I have 1/2. I have 1, 2, 3. I have 3. So there's my numerator. I have 3. My numerator is what I have. What do I have shaded in? I have 3. And what do my pieces look like? They look like halves. So my answer is 3 halves. Okay? Now, I already know what your brain's doing. You're looking over here going, oh, I figured it out. And you might have. Okay? What you probably noticed is that you took the whole number, you multiplied it by the numerator. And down here, well, your denominator, it looks like it just stayed the same, or you actually did something to it. But we'll talk about that later. But this denominator tells you what your pieces look like. My pieces look like halves, so that's what I'm counting up. I'm counting up halves. Okay? Now, there's another way to draw it that we can look at. Okay? So there's another way to draw Give me just a second. So I'm going to draw again. I'm going to draw it again. So here's one way. This is the one way. Okay. And now here is another way. Now this way here, I would say isn't any better or less, but I think maybe it shows us we understand fractions a little bit more. So again, what does it say? Let's start again. I want 3 of the 1/2 donuts. I want 3 of the 1/2 brownies. I want 3 of the 1/2 chocolate cake. I want 3 of the 1/2 candy bars. Whatever you want to think about. Okay. So what do I have? What you have goes last. So I have 1/2. So that's what I draw. I draw 1/2. I have 1/2. But I want 3 of the 1/2. So I want 3. Ultimately, what am I saying? I want 3 1/2s. Okay. So I'm going to shade in. There's 1 1/2, right? I'm even going to put a little 1 there. There's a 1. That's my 1. But instead of drawing a new 1/2 donut and eating it, couldn't I just eat the other half of this donut? I could just eat the other half of that donut, and then that's the second half. There's 2 halves now, but I still said I wanted 3 1/2 donuts. So then I would still have to get 1 more donut. My denominator tells me he's cut in half, so I cut him in half. And then because I wanted 3 1/2 donuts, there's the 1/2, there's the 2/2, there's the 3/2 right there. So there's my third piece. So again, if you come to look at it, this is 1 whole. Okay, so I had 1 whole donut and 1/2 donut. So you can see your answer is the same, just as a mixed number. So you could draw it to make it look like an improper fraction, or you could draw it to make it look like a mixed number. Both drawings are acceptable. Both drawings tell me the same thing. In this case, you could look at it like this, make it real life. I had 1/2 of a chocolate donut. I had 1/2 of a strawberry donut. I had 1/2 of a glazed donut. Here, you had a whole chocolate donut and a half of a strawberry donut. All the same amount, because when you put these 3 together, 1/2 plus 1/2 is 1 whole, and then you have the other half. So if we even did, we'd have to do the mixed number. How many 2 can go into 3 one time? 1 would be left, and that would be the same thing. So either way works. I think both of them are fine to do. Okay? So we'll do both ways. Sometimes I like this way to start it, and then I like to move to this way. But that's how you're going to multiply fractions. We're going to use some visuals to kind of help us until we start to see and understand what we could possibly do. Okay? So there was example 1. Let's do another example. And I said this might be 2 videos. I might just make it 1 because I can see I'm going a little bit long already. All right, so say I had 4 times 1/3. Okay, 4 times 1/3. Now again, for my doers, you might already be seeing it, be going, oh, I know what to do. It's going to be 4/3. You are correct. That's right. But do you understand? Do you understand why? Okay, so another thing you need to realize is, what did you start with here? Here I started with 1/2, and now I have 1.5. So my answer, like always, every time in multiplication you've always known, your answer went up. This is what you started with, 1/2, because again, what you have went second. So you started with this. This is the guy you look at. That's what I had. I ended up with this. My answer went higher. Okay? Now, let's look at this guy. And again, let's put the word of there, and we can even write the I want here. But what we're going to do every time is turn it into a word problem, or at least turn it to a word sentence to think about what's going on. Okay? So here you go. I want 4 of 1/3. And you got to come up with the 1/3. What do you want to stick with? Donuts? We can go to brownies. We can go to anything. I'm going to go candy bar here. Okay? I want 4 of 1/3 candy bars. I want 4 of the 1/3 candy bar. So you got to ask yourself, first question you always ask, what do you have? You have 1/3, so that's what you draw. I have 1/3. And you cut it into thirds. There's your 1/3 candy bar right there. How many do you want of the 1/3 candy bars? Second right here. What you are doing goes first. or what you want. So I wanted 4. So what do I need to do? I need to draw 4 candy bars. My denominator tells me what to cut them into. See how all our knowledge of fraction concepts that first week are now flowing into making this easier? If you forgot what a denominator is, it's going to be really challenging for you to focus on this. Okay, that's why all of this is a building process. Why did I just cut them all into thirds? Because my denominator is a third. He tells me what my pieces look like. Okay, why did I shade 1/3? Because I had 1/3. Okay, why did I draw 4 of them? Because I wanted 4 of the 1/3. And since I wanted 4 of 1/3, I have to shade in another third, another third, and another third. And I could say this was Snickers, this was Butterfinger, this was Twix, and this was Hershey's. And we can say that's why I wanted 4 different ones. So now I got to figure out, well, how much do I have? Okay, so count them up. 1/3, 2/3, 3/3, 4/3. I have 4/3 as an improper fraction. Now you got to be a mixed number. How many times can 3 go into 4? You could even divide it out like we're supposed to, where you would have the 3 and the 4. Oops, sorry. The 3 and the 4. How many times could 3 go into 4? 1 time. 1 times 3 is 3. 4 minus 3 is 1. Just to give a quick review. Okay. The 1 would go, that's your whole number. That's your numerator. That's your denominator. So if you forgot how to do that, there's a quick recap. So my answer would be 1 1/3. I get 1 1/3. So this is how this works. And I kind of use my hands. And we've done this before. If you take what you have and what you want and combine them, it's what you get. Remember that? What you have, what you want, what you get. So I get 1 1/3 candy bars. Even though they're separated like this, if I put them all together, they would be 1. I ate a total of 1 1/3 candy bars. Now, the other way to draw it, which again I would say is a little higher level thinking. It's when you're putting the pieces together, it kind of makes sense. So then we're going to say, okay, again, what do I have to start with? I had 1/3 candy bar. How did I know I had 1/3? Because what I have goes second. So here I have 1/3 candy bar. That's what I started with. Always start with what you start with. But now you wanted 4 of them. You wanted 4 1/3s. So instead of making another candy bar, can't I just add this 1/3? It's the same thing. This third and this third are the same, other than maybe a different candy bar. But as far as the amount, they're the same. So then instead of doing this, another candy bar and getting a third here, I'm just going to eat the other third of this candy bar. Now there's 3. That's 3/3, right? That's 3/3, but I was supposed to have 4/3. Okay, so I had 1/3, 1/3, 1/3. Okay, so now I'm going to make another candy bar. And again, I have to cut it into thirds because that's what my denominator tells me to do. But now I already have the 3/3. I wanted 4 of them. Now I just got to shade in 1 more. And now that's 1/3. And then there you go. How many full candy bars do I have? 1 full candy bar. How many candy bars of the second candy bar? I have only 1/3. And there's your answer. Okay? So what you're seeing here is that you can take it. And you can take the 4 times the 1/3, figure out what that means. I want 4 of 1/3. When you draw it out, this is how we're going to draw it out. This is what it's going to look like. Okay? Now, is there a shortcut to this? Yes. Is there a mathematical, computational, very fast way to do this? Yes. And I'm going to teach that to you in class. But I want you to fully come in understanding what you're doing here. Okay? You have a fraction. You want multiple of it. Okay? This guy is what we call the multiplier. Okay? In fact, I'm even going to put it up here. The first guy is called the multiplier. He is in charge of making your answer go higher because you wanted multiple of them. You wanted 4. Okay? We're going to talk later on when this guy's not a whole number, but we're not worried about that for today. Okay? We're not worried about that for today. So and please ignore the phone. Let's go ahead and do another one, and I'll do one more problem. Okay? So here's example problem number 3. All right. So let's have 2 times 1/5. okay, equals. And again, is there a good computational way? Yes, but I told you at the beginning of the video, if all that's what you do and that's all you concentrate and that's all you get out of this, you're gonna do poorly, or at least it's gonna be harder to understand when we get to the harder concepts, okay? So once I teach you the computational skill and how to go faster with this, you can't forget how it works. All right, so again, what does this mean? I'm gonna write the of here, the I want here. I want 2 of 1/5. And I'm going to stick with candy bars because I think they're easy and candy bars are normally long, and that's what I can have. So I have 1/5 of candy bar. So there's my 1/5. And again, are they perfect? No. Try to make them as good as you can, but be nice about it. Make them nice. Try to make them as even as possible. Don't be messy. Okay. Well, this is what we don't want. Okay. That's not what we're doing here. Okay. We're going slow to make sure we truly understand what's going on. So here's my 1/5. Let's go ahead and color it in. I have 1/5 right there. There's my 1/5. That represents what I have. So I have 1/5. But again, let's read it. I want 2 of 1/5 candy bars. Okay. So there's my 1/5. Again, I'll call this Snickers. But I'm going to draw another candy bar because I want 2 of them. And again, that's the important part. I want 2 of them. And if I didn't know this, if this didn't mean of, or if I didn't know that, this would be harder to understand. So this word's helping us out a lot. We're going to cut it into fifths because that's what our denominator tells us. And I know I want another 5th. Boom. There's my other 5th right there. And we'll call that, let's just call that Hershey's. Okay. So again, how many candy bars do I have? Okay. How much of the candy bars should I say do I have? Well, I have 1/5 and 1/5. So there's 1/5. There's 1/5. My answer, I have 2/5. Okay. And again, how would this work with the other drawing? I could make and again, these are just equivalent, same value, look different. So I can make my candy bar. I know it's cut into fifths. And instead of having 2 candy bars, I could just shade in 2 of the fifths because I know this 5th and this 5th are the same size as these 2 fifths. So then that would be 1/5 and that would be 1/5. So either way, my answer is 2/5. Your pictures could look a little different just depending on how you see it. Okay, so that's where we're going to stop. I was going to go on to the other method, but I'm not going to today. I'll just make a whole separate video on that. We weren't going to have you watch it today anyway. So hopefully this helps to get an understanding of how multiplying fractions work. So if you notice, our answer is still going up. So look, what did I start with in this last problem? 1/5 right there. But how many did I end up with? What did I get? 2/5. So I took what I have, multiplied it by what I want, and I got 2/5. So I started with 1/5. That's important because that's going to be another lesson down the road. So I'm already helping you with an understanding of something we're going to do later on. So pay attention to that. I have 1/5. I wanted 2 of them. I got 2/5. So I got more than I started with. So my answer still went up. Be tuned for next time because your answer doesn't always go up.